am Dr. Manoj Kumar Sharma, Associate Professor, IITS College of Pharmacy, Muradnagar. This is the lecture number 17 and it is the continuation of the parametric test and it is part 3. The subject is biostatics and research methodology. The code is BP801T and course is Bachelor in Pharmacy, the University Dr. APJ Abdul Kalam Technical University. In this lecture we read about ANOVA and the contents of the present lecture for what is F test and what are the ANOVA, then we define one way ANOVA, two way ANOVA, application of ANOVA and references. So, these are the contents for the present lecture. Now, first is introduction ANOVA. The analysis of variance or ANOVA is developed by R. A. Fisher in 1920. If the number of samples is more than 2, then the Z test and the T test cannot be used. The technique of variance of analysis developed by Fisher is very useful in such cases, and with its help it is possible to study the significance of the difference of the mean values of a large number of samples at the same time. The technique of variance of analysis originated in agriculture research, where the effect of various types of the soils on the output or the effect of the different types of fertilizers on production had to be studied. The technique of analysis of variance was extremely useful in all types of research. The variance analysis studies the significance of the difference in means by analyzing variance. So, we compare here variance, not mean. The variances would differ only when the means are significantly different. The technique of the analysis of variance as developed by Fisher capable of fruitful application in variety of problems. The null hypothesis for ANOVA is variability within the group equal to the variability between the this means, that means mu 1 equal to mu 2, that means variability between the group equal to the variability within the group. And the alternate hypothesis is the variability within the group does not equal to the variability between the group, or simply you can say mu 1 is not equal to mu 2. In ANOVA we apply F test. ANOVA measure two source of variation in the data and compare the relative sizes, and there are two types of variation. One is variation between the group. For each data value look at the differences between its group mean and the overall mean, and variation within the group. For each data value we look at the differences between the value and the mean of its group, and the total variation is equal to the variation between the groups plus variation within the group. The formula for F is variability between groups upon variability within the groups, and we have F statistic is equal to MSE upon MS. MSE is the mean sum of square between the sample divided by mean sum of square within the sample, and it is also called residual or error. MSE is also called residual or error. In FFA statistic we compare the value in inference with the tabulated value, and if our calculated value is greater than the tabulated value, then we reject the null hypothesis and vice versa. ANOVA is, when we classify the ANOVA, we have two types of ANOVA generally, one way ANOVA and two way ANOVA. One way ANOVA, in one way ANOVA classification we take into account only one variable, say the effect of different types of drug on pain on reduction. That means, in one way ANOVA when our data is classified on the basis of one characteristics. अगर आपका डेटा एक करेक्टरिस्टिक्स पर क्लासिफिकेशन है, एक ही ग्रुप से फैक्टराइज किया हुआ, फैक्टर 1 है, एक है उसमें, तब आप वन वे एनोवा लगाते हैं. अदर फैक्टर्स लाइक पेशेंट एज, जेंडर, वेट आर नॉट कंसिडर्ड. सो in this example we apply one way ANOVA. One way ANOVA, if we take example to understand one way ANOVA, if 4 drugs for a pain reduction are being studied, we have 4 samples, say 10 subjects, and conduct the experiment. We will note down the pain reduction on each one of the subject of various sample, and then with the help of F test we trying to find if there is a significant difference in the means of pain reduction given by 4 drugs. To understand one way ANOVA, I show this slide. If we have 3 treatments 1, 2, 3 and the replicates are and the sample size is 3, that means we have 3 treatment groups and in each treatment we have 3 samples, then the observation of first sample is x11, that means first sample first treatment, this is first sample second treatment and this is first sample third treatment. Next x21, this is the second sample, but treatment is first. In x22 sample is second, treatment is 2 and these are the in the similar manner x31, x32 and x33. The sum of first sample is shown first treatment is shown by summation xc1. Sum of the second treatment group show by summation xc2 and the third treatment is summation xc3. Steps in one way ANOVA are: we will start with the help of null hypothesis, that is the mean yield of the 4 drugs or fertilizer is non-different in the universe. So, H naught equal to mu 1 equal to mu 2 equal to mu 3 equal to mu 4, and the alternate hypothesis will be H naught mu 1 is not equal to mu 2 is not equal to mu 3 is not equal to mu 4. That means, in alternate hypothesis we consider there is a significant difference between the all 4 means, while in the null hypothesis we consider there is no significant difference between the 4 means. And the second step, we first find the correction factor. To find the correction factor, we first find the grand total G equal to summation xc1 plus summation xc2 plus summation x3, and the correction factor will be equal to G square upon n. Then we find the total sum of square or of the samples. You can write it as SST and it is equal to the summation xc1 square plus summation xc2 square plus summation xc3 square minus correction factor. Then we find the sum of square between the samples or columns. This is write as SSC and it will be equal to summation xc1 square upon nc1 plus summation xc2 square upon n2 plus summation xc3 square upon nc3 minus correction factor or G square by n, where nc1 is the number of elements in the first column, nc2 is the number of elements in the second column, nc3 is the number of element in the third column. Then we find the sum of square within the sample. As we know, the total sum of square equal to the sum of square between samples plus sum of square within sample, between samples and within sample. So, sum of square within sample calculated by we subtract the sum of square within sample from the total sum of square. Then we find the degree of freedom. The degree of freedom between the sample is V1 equal to C minus 1 and the degree of freedom within the sample V2 is equal to n minus C. N is the total number of observation minus C, C means total number of treatment or columns. Next we find the mean sum of square columns divide by mean sum of square कैसे निकलेगा, आप क्या करेंगे, जो आपका सम ऑफ स्क्वायर बिटवीन सैंपल है उसको डिग्री ऑफ फ्रीडम से डिवाइड कर देंगे. सिमिलरली मीन सम ऑफ स्क्वायर विद इन सैंपल जिसे आप रेजिडुअल या एरर कहेंगे, उसमें आप क्या करेंगे, सम ऑफ स्क्वायर विद इन सैंपल को जो डिग्री ऑफ फ्रीडम है V2 उससे डिवाइड कर देंगे एंड यू विल गेट द मीन सम ऑफ स्क्वायर विद इन सैंपल. देन वी अप्लाई एफ टेस्ट, एफ इक्वल टू MSC upon MSE. Be remember the value of f is always greater than 1. This is the most important point. F is the greater than 1. So, if MSC greater than MSE, then you apply f equal to MSC upon MSE, while if MSE is greater than MSC mean sum of square between sample, then you apply f MSE divide by MSC because the value of f is always greater than 1. And last point, conclusion or inference, and if our calculated value of f is less than the tabulated of f, then we accept null hypothesis at given level of significance and degree of freedom and vice versa. This is the ANOVA table in which the first is source of variation. The source of variation are two types, between the samples and within the samples. As samples in column, so you may also write as between the columns, and the next column is degree of freedom, where degree of freedom between sample is C minus 1. Next is sum of square, that is SSE, sum of square between samples. Next mean sum of square, this is the mean sum of square between sample. For this we divide sum of square between sample by the degree of freedom V1, and in the last within samples this is residual, degree of freedom is n minus c, which these all value we have already calculated initially. Sum of square within the samples, mean sum of square within the sample equal to the sum of square within the sample divided by degree of freedom, and then we calculate the f, and this calculated f compare with the tabulated f. In two-way classification, in one-way classification we take into account effect only one variable, while if there is two-way classification, the effects of two variables can be studied. The procedure of analysis in two-way classification is total both the columns and rows. The effect of one factor is studied through the columns wise figures and the total, and the other through the row wise figures and totals. For example, we want to compare the change in pain reduction by a drug, and we also check the effect of the drug on male or female. तो अगर आप पेन रिडक्शन एक आपके पास वेरिएबल है, आप उसको ये कंपेयर करना चाहते हैं कि कौन दो ड्रग हैं आपके पास, कौन सी ड्रग बेटर आपका पेन रिडक्शन करती है. सेकंड, क्या वो मेल पर ज़्यादा इफेक्टिव है या फीमेल पर ज़्यादा इफेक्टिव है. तो यहाँ पर पेन रिडक्शन जो है वो आपका दो फैक्टर पर डिपेंड करेगा, एक ड्रग पर जो आप ड्रग ट्रीटमेंट दे रहे हैं, सेकंड जेंडर पर. तो इस केस में आपका क्लासिफिकेशन जो है टू वे क्लासिफिकेशन होगा. तो in two-way classification the effect, the variances are calculated for both the columns and rows, and they are compared with the residual variances or error. The steps for two-way ANOVA, we will start with the null hypothesis, that is the mean yield of 4 fields is not different in the universe. that is mu 1 equal to mu 2 equal to mu 3 equal to mu 4. The alternate hypothesis is all are not equal, that means mu 1 is not equal to mu 2 and it is not equal to mu 3 and mu 4. Then we compute the grand total and this will be equal to the sum of first column plus sum of second column plus sum of third column. Then we calculate the correction factor equal to the grand total square divided by n. Now we find the total sum of square SST, this is same as sum of square first column plus sum of square of second and sum of square of third column values minus correction factor. Then we find the sum of square between columns SSC, this will be equal to B minus D and sum of it will be equal to summation x C1 whole square divided by n C1, where n C1 is the number of observation in first column, summation x C2 square upon n C2 plus summation x C3 square upon n C3 minus correction factor, where n C1 are number of elements in the first column, n C2 are the number of columns in second column and n C3 are the number of observation in third column. Then we find the sum of square between rows. This is another one more step in comparison of one way ANOVA, sum of square between rows SSR, and this will be equal to sum of x R1 upon n R1 plus sum of n x R2 upon n R2 plus sum of x R3 upon n R3 minus correction factor, where n R1 are the number of elements in the first row and n R2 is the number of elements in second row and n R3 is the number of elements in the third row, and sum x R2 is the sum of the square of the value in rows, and the next step is sum of square within the samples, and this is equal to the total sum of square minus total sum of square between column and total sum of square for rows. Then we find the degree of freedom between sample V1 equal to C minus 1. The number degree of freedom between rows is V2 equal to R minus 1, R is the number of rows. The number of degree of freedom within the sample V3 equal to the C minus 1 into R minus 1. Then we find the mean sum of square and between the columns. For this we divide sum of square between sample divided by degree of freedom V1 and mean sum of square between rows equal to the sum of square between rows divided by V2, mean sum of square within sample equal to the MSC or residual, it is also called residual sum of square in samples divided by V3. Now we apply the F test. Here we find the 2 F, first F for MSE upon MSC upon MSE between columns के लिए and second F between rows के लिए F MSR divided by MSC, and be remember denominator should be less than the numerator as the value of F is always greater than 1. And this is the ANOVA table for two-way ANOVA. First is source of variation, and the source of variation first is between columns. The degree of freedom between columns is C minus 1, sum of square SSC between columns, then we write mean sum of square between column, then we apply F ratio. Next is source of variation between replication or rows. For this degree of freedom is V2 R minus 1, sum of square is SSR, and next is mean sum of square between rows equal to SSR divided by degree of freedom, and third is residual, that means the source of variation within the samples. The source of variation within the samples is called residual or error, and it will be the degree of freedom for this is C minus 1 and R minus 1, and the sum of square equal to, इसमें क्या करेंगे हम टोटल सम ऑफ स्क्वायर में से sum of square between sample and sum of square within rows, दोनों को माइनस कर देंगे. Then we find the mean sum of square for residual, and this will be equal to sum of square of within sample or residual divided by the degree of freedom V3, and we apply F test. Now, the application of ANOVA. ANOVA is the synthesis of several ideas and it is used for multiple purpose. The statistical analysis depends on the design and discussion of ANOVA, therefore, includes cannot common statistical design used in pharmaceutical research. Compare heights of plant with and without galls, or compare birth weights of deer in different geographical area, or we want to compare pain reduction, for example, by the 4 or 5 treatments. ANOVA particularly applicable to experiment otherwise difficult to implement, such as in case clinical trial. In the bioequivalence studies, similarities between the samples will be analyzed with the ANOVA only. Pharmacokinetic data also will be evaluated using ANOVA, and pharmacodynamics, what drugs does not the body, data also be analyzed with the help of ANOVA only. The means we can analyze our drugs is showing significant in pharmacological action or not. We can compare responses of patient to real medication versus placebo. We also compare attention spans of undergraduate students in different program of PC. Now, to understand the one way ANOVA, we take an example. This is a dissolution is compared for 3 experimental batches with the following result. Each point is time in minutes for 50% dissolution of a single tablet. So, in this we have 3 types of batch of tablets, and the 50% dissolution of single time is given for each sample. In batch 1 we have 5 samples, in batch 2 also we have 5 samples, in batch 3 we have also 5 samples. So, here the dissolution is depend upon only the 3 types of batches of tablets. So, we apply here one way ANOVA. So, for this, first of all we find the sum of for the given test, the problem is there a significant difference in the dissolution of 3 batches, the level of significance of 5%. First, the null hypothesis, we consider there is no significant difference in the means of 3 samples. So, you will write here mu 1 equal to mu 2 equal to mu 3, and alternate hypothesis mu 1 is not equal to mu 2 and it is also not equal to mu 3. The alpha is 5% and the degree of freedom between samples is C minus 1, C are 3 columns. So, it will equal to 2, and within the sample is n minus C, and our total observations are 15 and the number of columns are 3. So, 15 minus 3 equal to 12. To do solve is, first we find the sum of x 1, this is summation x 1, x c 1, this is summation x c 1, this is summation x c 2, this is summation x c 3, and these are the square of x 1 square values. So, first of all we find the sum of x 1, x 2, x 3, then we find the x 1 square, x 1 square, x 2 square and x 3 square. This is x 1 square, x 2 square and x 3 square. Squaring the value and find the sum of these values. So, this is the summation x c 1 square, summation x c 2 square and summation x c 3 square. We find these sum, then we find the grand total summation x 1, x 2, x 3. this will be 150. The correction factor is equal to grand total square by n, 150 square by 15, this will be equal to 1500. Then we find the total sum of square, this will be equal to x7 square, put these values we find 100, and the sum of square between samples on putting the squaring values and subtract the correction factor, we find this is 40. Then we find the sum of square within sample, this is equal to SS equal to SST minus SSC, this will equal to 100 minus 40 equal to 60. Now we put these values in the ANOVA table and we find the mean sum of square 40 by 2 and mean sum of square within sample is 60 by 12, divide it, these value divide by the degree of freedom, and we find the value of f is 4. So, this is the calculated value of 4. Now, the tabulated value f at 5% for degree of freedom 2 and 12 is 3.88, but our calculated value is 4. So, we reject the null hypothesis, or you can say we accept the null hypothesis, and we say there is a significant difference in the means of desolation rate of 3 batches. Thank you.